All right. Today we're learning comparing real numbers. This is really similar to pre-1-1, except for pre-1-1 just had us labeling the numbers as what they were. This one is actually going to compare them, so how the numbers compare to one another. So we've got a little real-world application here. It says on our model, the distance from the pitching mound to home plate is 1.3 inches. Is 1.3 a rational number? If you remember, rational numbers are fractions, decimals, and those decimals have to be terminating or repeating. So does 1.3 fall in here somewhere? Yep, it's a terminating decimal. So yes, it's a terminating decimal. Okay, they're going to ask us a few more questions about this home plate over here. It says on the model, the distance from first base to second base is 2 inches. Oops, 2 inches. Is 2 inches a rational number? Well, yes. It's, you could say it's a terminating decimal because it's 2.0. You could say it's a fraction, 2.2/1, or you could say it's a natural number. And natural numbers are automatically rational numbers. The distance from home plate to second base is the square root of 8 inches. Using a calculator, find the square root of 8. So this is a good opportunity to talk about calculator misconceptions. So if we type in the square root of 8, does it appear to terminate or repeat? It appears to terminate. To determine if it terminates on your calculator, multiply your answer to the square root of 8 by itself. So don't use the x squared button. So we need to take this answer, and I'm going to write this one down. So I'm going to multiply what's in my calculator times 2.828427125. Now it's supposed to give me this ugly decimal, and because it has a 1 at the end, it's not a perfect 8. Is the answer 8? No. Based on results, can you classify the square root of 8? So is there a number that exists times itself that gives you the square root of 8? The answer is no. And another way to explain that is or you can say the square root of 8 is not a perfect square. Remember, a perfect square had to be two whole numbers, two integers multiplied together to give you a whole. All right. So moving on to slide 3. You've seen this before, so I'm just going to skip that. We talked about it in pre-1-1. Do have two vocab words. An irrational number is a number that cannot be expressed as the ratio of a to b, where a and b are integers and b does not equal 0. So, good example here. Or you could also write this as a non-terminating, non-repeating decimal. Numbers that are not rational are called irrational. We've talked about those. The square root of any number that is not a perfect square number is irrational. The set of rational numbers and the set of irrational numbers together make up the set of real numbers. So we were talking about how every number that we talk about in here is a real number. Someday you'll talk about imaginary numbers. So again, this is that N, W, I, R, and then irrational being separate. Natural, whole, integer, rational, and irrational. So if it's a natural, it's all of them along the arrow. If it's none of them, it might be irrational. So we've done this before. It should be quick. This is a repeating decimal, makes it a rational number, and a real. So all of these are real. Square root of 36 simplifies 6. That's a natural. So that would be all of them since it's natural. Does a square root of 7 have a perfect integer that you can square? No, this is irrational. Same story for the square root of 10. No whole number times itself gives you 10, so this is an irrational number. This is a fraction, so that falls under rational. And this square root is 10. So this is a natural number, which makes it the rest. Okay, new stuff for this lesson is comparing and ordering them. So it says you can compare and order real numbers by writing them in the same notation. Write the numbers in decimal notation before comparing or ordering them. So the square root of 7 is somewhere bigger than the square root of 4, somewhere so bigger than 2, less than 3. So if you type that in your calculator, oh my gosh, typing the right button, 2.646 rounded thousandth, 2 and 2/3. Hopefully you know that is 2.6 repeating, so 2.667. Which one's larger? This one, because the second 6. 15.7%, that's 0.157, 2 spots. Square root of 0.02, 0.1414, and that's enough because the 5 is larger. This is 3.333. Square root of 11 is 3 point something because that's larger than the square root of 9. 3.317. We could stop at the hundredths because 3 is larger than 1. So decimal notation is super helpful there. It's also going to be helpful to order them from least to greatest to get them all in the same notation. So I'm going to write them out to the thousandth. This is 6.000. This is 5.8. 5.367. If we rounded the 6. Square root of 30. 5.477. So somewhere between 5 and 6. So I'm going to go ahead and 5, 6. But when I put them on the number line, it's going to be in their actual form. So 5.1, 5.2, 5.3, 5.4, 6, 7, 8, 9, 6. Okay. So roughly, square root of 30, 5.47. So 5.4, a little over half, about here. 6, 6. 5.8. 5, 6, 7, 8. And 5.367, so about here. And that was 5.36 repeating. All right. Same thing here, least to greatest. These are all in the negatives, so we got to be careful about that. -7, we can graph that one already. Negative square root of 60, so square root of 60. And then negative in front of that, negative 7.746. 7.746. This is negative 7.7. And last one, 7.333. So 7.333, a little more. Negative, oh my gosh, negative 66 over 9. Negative 7.7. It's negative 7 7/10. Square root of 60, 7.746, so probably down here, and I'm just going to label that one down here. There we go. So it helps visualize from least to greatest. Last one. On a clear day, the number of miles a person can see to the horizon is about 1.23 times the square root of his or her distance from the ground in feet. So 1.23 times the square root of the distance from their feet from the ground. Suppose Frida is at the Empire Building observation deck at 1,250 feet, and Kia is at the Freedom Tower here. How much farther can Kia? Well, it's because this is larger than this number. This person can see farther, but they're asking how much farther. So how much farther means a subtraction problem once we know how far they can see. So for Kia, it's going to be 1.23 times the square root of 1,362 minus Frida, which is the square root, or 1.23 times the square root of 1,250. So we'll round it to the nearest foot. 45 miles, I guess. We'll round to the nearest mile. Yeah, number of miles. 45 miles. And this one is 43 miles. So about 2 miles equals 2. So about, oh my gosh, this lead. And there we have it, about 2 miles. They can see farther. And that's only a difference of 112 feet. Wow. Stars can't shine without darkness. Have a great day.